Welcome back, everybody, to another deep dive. Today, we're tackling a question that's been on humanity's mind for, well, probably as long as we've been looking up at the stars. Are we living in the best possible universe?
Definitely a big one.
And before anyone gets any ideas, this isn't about, perfect weather or winning lottery tickets or anything like that. We're talking about the universe's capacity to actually support life.
Right, the nitty-gritty cosmic conditions that make life as we know it possible at all.
And lucky for us, one of our listeners sent in this fascinating study that was just published in the monthly notices of the Royal Astronomical Society.
Yes, this one really gets into some deep stuff.
It really does. Basically, it suggests that our universe, while pretty darn good for life, may not be the absolute best.
Yeah, in terms of maximizing the potential for life to emerge and thrive, there might be even better setups out there.
Which is a pretty wild thought,
Yeah.
especially since this study reached these conclusions without, resorting to any supernatural explanations or anything.
Exactly. It's all based on observations and simulations. Good old-fashioned science.
So how do they even begin to figure this out? We can't exactly go universe hopping to compare notes, or can we?
Not yet, at least. But they started with a tool that anyone who's ever pondered the likelihood of aliens is probably familiar with, the Drake equation.
Right, the Drake equation. It's like a cosmic recipe for life, isn't it? All the ingredients you need to cook up some intelligent beings.
You got it. It takes into account things like the rate of star formation, the fraction of stars with planets, how many of those planets are habitable, whole bunch of factors.
Okay, so that's the classic Drake equation. But this study added a new ingredient to the mix, something a little mysterious.
They did. They factored in dark energy.
Dark energy. Okay, so for anyone just joining us, dark energy is this, well, it's this force that's pushing everything in the universe apart at an accelerating rate.
And the thing is, we can't directly observe it. We just know it's there because of its effects on the cosmos.
Right, so we can't see it, but it's like this invisible hand shaping the universe.
A very powerful hand at that.
And the researchers are saying it could actually play a role in how stars are born.
That's what their findings suggest.
Yeah.
Which is huge. Because stars are like the cosmic engines that create the building blocks for planets and ultimately for life itself.
So this invisible force that's pushing everything apart could actually be helping to create the conditions for life. That's pretty mind-blowing.
It is. And it gets even more interesting. The study found that in our universe, about 23% of all matter eventually ends up forming stars.
Okay, so 23% of all that stuff out there eventually becomes a star. That seems pretty good, right?
Yeah, it's definitely conducive to life. But here's where things get really fascinating. They didn't stop there. They went a step further and created computer simulations of other universes.
Wait, so they're like playing cosmic architect in the virtual world, creating their own universes and seeing what happens.
Exactly. They're tweaking the settings of these universes and seeing how they evolve.
So in this case, what setting did they tweak?
The amount of dark energy.
Ah, so they're messing with that invisible hand. What happens when you give it a little more power? Or a little less?
Well, the results were pretty surprising.
Yeah.
Some of the simulated universes, the ones with slightly more dark energy than ours, actually had higher rates of star formation.
Really? More dark energy equals more stars? I would thought it would be the opposite. Like, wouldn't more dark energy pushing everything apart make it harder for matter to clump together and form stars?
That's a great question, and it really highlights the complex interplay between dark energy and gravity. See, it's not just about the amount of dark energy. It's about how it interacts with gravity over these vast cosmic timescales. It seems like a slightly higher amount of dark energy, at least in these simulations, can actually create conditions that are more favorable for star formation in the early universe.
Huh, so it's like giving the universe a little extra push to get those stars going.
Yeah, kind of. And the study found that some of those simulated universes had a star formation rate of up to 27%. That's significantly more than the 23% we see in our own universe.
Wow. Okay, so more dark energy potentially means more stars, and that could mean...
More planets, more chances for life. It really makes you think about what makes a universe ideal for life.
It's not just about finding an Earth 2.0 anymore. It's about understanding these fundamental forces at play.
Exactly. And how those forces can either help or hinder the emergence of life in the first place. Which brings us to a pretty interesting philosophical idea.
Oh, lay it on me.
The best of all possible worlds.
Ooh, I like where this is going. Okay, so for anyone who hasn't spent their Friday nights debating philosophy, the best of all possible worlds is this idea that, Well, basically, that our universe must be the best possible one because, well, here we are, right? If it wasn't optimal for life, we wouldn't exist to ponder such questions.
Exactly. It was popularized by a philosopher named Gottfried Leibniz back in the 17th century.
Long before we knew about dark energy or the vastness of the cosmos or any of that stuff.
Right. So it's fascinating to think about how these new findings about dark energy and star formation fit in with Leibniz's ideas.
Hmm.
Does the possibility of universes that are even more life-friendly than ours kind of throw a wrench into his whole best possible world theory?
Right, because if there are universes out there that are even better at creating stars and planets and life, then maybe our universe isn't the top of the line.
That's a great point. And it really highlights the intersection of science and philosophy. Because on the one hand, this study suggests that our universe might not be perfectly optimized for life. There could be other universes out there that are doing even better.
So does that mean Leibniz was wrong?
Well, not necessarily.
Hmm.
Remember, Leibniz was considering best in a much broader sense.
Yeah.
He was thinking about the overall balance of good and evil, happiness and suffering, things we can't really measure scientifically.
So maybe those other universes with tons of stars and planets also have downsides we haven't even considered.
Exactly.
Mm.
Maybe they're more prone to cosmic catastrophes, or maybe that abundance of life leads to constant conflict and competition. Who knows?
Right. We're kind of looking at this through a very specific lens, the lens of how good is this universe at making life?
Exactly. We simply don't have enough information to say for sure whether those other universes would be better overall. It's like comparing apples and oranges. Each universe might have its own unique set of advantages and disadvantages.
Okay, so maybe we're not living in the absolute best possible universe. But hey, it sounds like we're doing pretty well.
We're definitely not doing too bad.
It's like, you discover that your favorite local bakery makes a pretty amazing chocolate cake, but then you hear rumors of this legendary cake maker across town who might have them beat.
I see where you're going with this.
You're still going to enjoy your local cake, right?
Okay.
But you're definitely curious to try the other one.
Exactly. And that curiosity is what drives scientific exploration. We may never know for sure if other universes exist or what they're like, but the very act of asking these questions and searching for answers expands our understanding of our own universe.
And it pushes us to think beyond our limited perspective.
Absolutely. It's almost as if this study is suggesting that the universe isn't this static finished product. It's more like an ongoing experiment.
With all these different possibilities playing out.
And some of those possibilities might be more conducive to life than others.
Which is a pretty humbling thought. I mean, even without invoking any supernatural explanations or divine intervention or anything, this study is basically saying that our universe seems remarkably well suited for life, almost like a happy cosmic coincidence.
Yeah, or maybe a hint of something deeper. Who knows?
We might never know for sure, but it's certainly fun to think about.
Definitely. And you know what else is fun to think about?
Oh, I know you're going to say it.
All those other universes out there, if they exist, what are they like? Are they teeming with life or are they barren and hostile?
Do they have different laws of physics? Different dimensions? Ugh, so many questions.
And we're just starting to scratch the surface. It's exciting.
It really is.
Yeah.
And it's amazing to think that just a simple question like, is our universe the best possible one, can lead to so many incredible discoveries.
It's a testament to the power of curiosity.
Right, and the power of the scientific process. I mean, this study didn't invoke any supernatural explanations. It stuck to observations and simulations. And yet, it still managed to reach this profound conclusion that our universe seems remarkably well-suited for life.
It's pretty remarkable when you think about it.
It really is, and it leaves us with so much to contemplate.
Like what?
Well, like, if we could somehow fine-tune the universe, would we? Would we crank up the dark energy to make more stars?
Or maybe tweak the laws of physics to create something entirely new.
Or would we just leave things as they are, marveling at the beauty and complexity of it all?
That's a tough one. It makes you think about the potential consequences of our actions on a cosmic scale.
It really does. But hey, that's what makes this deep dive so fascinating. It's not just about the answers, it's about the questions and the journey of exploration they inspire.
Couldn't have said it better myself.
So on that note of cosmic wonder, I think we've reached the end of our deep dive for today.
Time flies when you're talking about the universe.
It really does. We've covered a lot of ground: dark energies, simulated universes, the philosophy of Leibniz. We even touched on the implications of our ability to understand and potentially manipulate the universe.
Not bad for one study.
Not bad at all. But as always, we want to leave you with something to think about.
Right, hit me with it.
If you were the cosmic architect, if you had the power to fine-tune the universe, what would you change? Would you create more stars, alter the laws of physics, or just leave it as it is? The choice, at least for now, is yours.
A lot to ponder.
It is. But that's the beauty of it all. Keep exploring, keep questioning, and keep looking up at the stars. Until next time.